6.3 is on page 323, talks about the matrix algebra or algebra of matrices. A matrix is defined by a rectangular array of numbers in which you look at how many rows you have. Row 1, we did that already. Row 2, all the way to r sub m. So this is m rows, and column 1, column 2, column 3, all the way to the n columns. And we say this is a matrix. The book will use capital letter for matrices. This is an m by n matrix. So you always state the number of rows first, then the number of columns. That's a must. To add or subtract matrices, they must have the same dimensions. They must match. You can't add matrices if the dimensions are not the same. And if you multiply a matrix, remember, an easier way of putting this, a matrix is a list of vectors. So it has some properties other than numbers. If you multiply a vector by a constant, well, don't you end up multiplying the components? Same deal here. If k happens to be a constant and multiply a matrix by it, that means you multiply all the terms, all the entries in the matrix by that value of k. And two matrices are equal if and only if the entries match identically. Every entry matches its correspondence, depending on which matrix you're looking at. Let me look at some examples. So we're looking at these matrices right there. We have A. A is a 2 by 3. B is a 2 by 3. And C is a 3 by 2. So if I was to look at taking A minus B, well, you want to put them in order. And the way you would add or subtract matrices, you would add or subtract the corresponding entries. So if I glance at those are corresponding, those are corresponding, and those are corresponding. That is, you simply add a 2 by 3, you end up with a 2 by 3. That doesn't change. That's the same thing. And you would take 0 minus a 4, that's a negative 4. 3 minus a 1, that's a 2. And negative 5 minus 0 is a negative 5. Then you get to the second, and you take 1 minus a negative 2, that's a 3. 2 minus a 3, that's a negative 1. And 6 minus a negative 2 is an 8. There it is. And if you take negative 3b, that's negative 3, and you write matrix B, 4, 1, 0, negative 2, 3, negative 2. And if you multiply that by a negative 3, that's a negative 12, a negative 3, a 0, a 6, a negative 9, and a 6. And that would be your final answer. And if I take 2a plus 4b, well, that would be, let's see, what's 2a? Multiply all the entries by 2, that's a 0, 6, negative 10, a 2, 4, and a 12, plus 4b. If I multiply all of these entries by 4, that's 16, a 4, and a 0, a negative 8, a 12, and a negative 8. And if I add those entries accordingly, I will end up with a 2 by 3. And the first entry will be 0 plus 16, 6 plus 4, and negative 10 plus 0. And a 2 minus 8, a 4 plus 12, and a 12 minus 8. And there it is, 2 by 3. Now, if they were to say, find A minus C, A is a 2 by 3, as you see, and C is a 3 by 2. Well, that's not possible. I can only add matrices that have the same dimensions. Matrix multiplication is the tough part. That's really what we're going to conclude here. multiply matrices, it's a bit trickier. If you take a matrix A, which is m by n, and multiply by matrix B, which is b by n, I don't want to clutter this. Let me use highlight. If this is m by n, and this is n by l, the inners must match. So the inner dimensions must match. They must be the same. Otherwise, the multiplication is not possible. And the outcome would be the outer limits. So that's how we do those. So if I'm looking at those, for example, I'm looking at BC. If I look at B up there, B is 4, 1, 0, negative 2, 3, negative 2. And C happens to be 4, 6, negative 2, a 1, a 2, and a 3. So, if I want to multiply those, before I would go ahead and do all of the work, I'll look at B and say, well, B is a 2 by 3. And C is a 3 by 2. The inners match. Not only that, I know what the outcome is. The outcome is a 2 by 2. My full answer would be simply 2 by 2. And this is how it works. A bit challenging. To generate this first row, I must use this first row. To get this entry, I use the first entry. To get the second entry, I use the second entry. And the way it works, you multiply horizontal by vertical. So, the first times the first, 4 times 4, plus 1 times 6, plus 0 times negative 2. So that's why they must match. That's why the inners must match. If there are 3 of those, you need 3 of those. And I would have used highlight only, but I want to make sure this is accessible by everybody. Some students have a hard time seeing certain colors. If I want to find the second, I would use the second. And the same idea. 4 times 1 plus 1 times 2 plus 0 times 3. So that first row actually turns out to be 22 and a 6. For the second row, I use the second row. And that's really how you separate between those. And then, the same deal. It's really the same work over and over, but it takes a bit of practice until we get the hang of this. So to get the first entry, I use the first. That is negative 2 times 4, negative 8, and in order. Plus 3 times 2, that's 18. Plus a negative 2 times negative 2, that's a 4. And to get the second entry, use the second entry. Negative 2 times 1 in that order. That's a negative 2. 3 times a 2 is a 6. And a negative 2 times a 3 is a negative 6. That would be a 14, and that would be a negative 2. So it's going to take a bit of practice, but I need you to really get that out of the way so you have enough homework problems to practice. And let's look at the next example. How about CB? Notice what BC is. BC is a 2 by 2. How about CB? How about if I put C first? C is 4, 6, negative 2, a 1, a 2, and a 3. And B is, you could put it anywhere you want, a 4, 1, 0, negative 2, 3, negative 2. This is a 3 by 2. This is a 2 by 3. The product is allowed. And the outcome is a 3 by 3. So the outcome is really a 3 by 3. And how does it work? To generate the first row, I use the first row. If I want the first entry, I use the first column. And the ordering 4 times 4 plus 1 times -2. That right there is a 14. If I want the second, remember this is still the first row, I'm going to stick with the first row all over. That's the best way to remember this. To get the second entry, I use the second entry. That's how I get this. And I'll take 4 times 1, that's a 4, plus 1 times 3, that's a 3, that's a 7. And to get the last entry, I use the last. 4 times 0, that's a 0, plus a -2, that's a -2. Now to generate the second row, I would use the second rule. That is, to generate this row, I would really use this row. And the same deal. To get the first, you use the first. 6 times 4 is 24. 2 plus a -2, that's a 24. And for the second, 6 times 1 is 6. And 2 times 3 is a 6, that's a 12. And for the last, 6 times 0 is a 0. And a 2 times a -2 is a -2. That gives you a -2. Let me clean that up just a bit. Just a bit. That's a bit more than a bit. Alright, here we go. Cluttered all of these values. Okay, and to get the last entry, or the last row I mean, I use the last row and the same deal. First I take this times this in order. That's a -8 minus a 6. That's -14. For the second, a -2 plus a 9. And for the last, a -2 plus a -6. That would be a -8. I don't write the 7. And there it is, 3 by 3. And there's this homework. I needed to get this homework before we go on to the next.